Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on voltaic cells. In our last lesson, we learned about different types of voltaic cells, including primary and secondary cells. Primary cells use redox reactions, which means that they cannot be returned to their original state by recharging. When the redox reaction is complete, these batteries must be discarded. We learned that primary batteries are not reusable. We learned that secondary batteries are reusable, and the reactions that take place in these cells can be returned to their original state or reversed by recharging. We also spent some time discussing types of primary cells, including dry cells, alkaline cells, and mercury cells. In today's lesson, we are going to focus on different types of secondary cells and fuel cells. We will identify the cathode and anode on these cells and compare and contrast voltaic cells with electrolytic cells. Let us get started. The first type of secondary cell we are going to talk about is the nickel-cadmium battery. Opposite to dry cells, which are not rechargeable and must be replaced frequently, the nickel-cadmium battery is very energy efficient. It is often used to power things like battery-operated tools and portable computers. The cadmium metal serves as the anode, and the nickel oxide serves as the cathode. Students, let us do an activity. Please write the half reaction for each electrode. Remember that these are reactions within a rechargeable cell, so the reactions are reversible.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to write the half reaction for each electrode? Please compare your answers to these ones. I am sure you remembered to put an arrow that moves in both directions because these reactions are reversible. If these were your answers, then great work. Let us continue with our lesson. The solid reaction products, nickel hydroxide and cadmium hydroxide, adhere to the electrodes. This allows the reactions to be reversed during charging. Let us move on to the lead storage battery, which is another type of secondary cell with reversible reactions. This type of battery is often used in automobiles. As you can see in this image, a lead storage battery is made up of 6 identical cells that are joined together in a series. Each of these cells has a lead anode and a cathode made from lead 4 oxide packed on a metal plate. Both electrodes are immersed in an aqueous solution of sulfuric acid, which acts as the electrolyte. Under normal operating conditions, each cell in the series produces 2 volts. Thus, each lead storage battery produces 12 volts and can deliver a large amount of current in a short amount of time. Students, let us do another activity. As we already learned, lead storage batteries are often used in automobiles. What are the characteristics of this type of battery that make it ideal for this use?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. What makes lead storage batteries ideal for use in automobiles? If you said they are ideal because they are rechargeable, you are correct. You were also correct to say that these batteries work well in automobiles because they can deliver a large amount of current in a short amount of time, such as the time it takes to start up the engine. Let us now learn about fuel cells. Fuel cells are electrochemical cells that convert energy from a fuel into electrical energy. They require a continuous supply of reactants to keep functioning. In its simplest form, which is shown in this image, a hydrogen-oxygen fuel cell is made up of an electrolyte solution such as sodium hydroxide or potassium hydroxide solution and two inert electrodes. The hydrogen and oxygen gases bubble through the anode and the cathode compartments. Combustion reactions are redox reactions, and it is therefore more desirable to carry them out directly by electrochemical means. This makes the production of power much more efficient and is an objective that can be accomplished by fuel cells. The cell reaction for fuel cells is spontaneous under standard conditions. However, unlike batteries, fuel cells do not store energy. As we already learned, not only are reactants continuously supplied, but also the products must be continuously removed. Students, this is what the half reactions and overall reaction looks like for the fuel cell. The standard reduction potential can be calculated by looking at this table, which we have seen before. Students, this is what the standard reduction potential for a fuel cell looks like. Let us clarify the difference between voltaic cells with electrolytic cells. While both contain two electrodes in contact with an electrolyte, they each create different types of energy. A voltaic cell is an electrochemical cell that gets electrical energy from chemical reactions. Electrolytic cells decompose chemical compounds using electrical energy in a process called electrolysis. In today's lesson, we learned about different types of secondary cells. We discussed the nickel-cadmium battery, the lead storage battery, and fuel cells. We also reviewed the differences between primary and secondary cells and compared and contrasted electrolytic and voltaic cells. This is all the time we have for today's lesson. In our next lesson of voltaic cells, we will discuss about corrosion of metals. Until next time, stay charged up. Thank you, teacher. Thank you, students.